Good evening. The subject name is Power Plant Engineering. The subject code is M.EZHILAN. I am Dr. M.EZHILAN, Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Today we are going to see the nuclear power plant. First, we have to see the main components of nuclear power plant. First one, nuclear reactor. Second one, heat exchanger or steam generator. Third one, steam turbine. Fourth one, condenser. Last one, electric generator. This is a layout of and substation of nuclear power plant. In nuclear power plant, the reactor function is similar to the furnace of steam power plant. It contains pressure vessels, fuel rods, moderator, shielding, as shown in the figure. There are various types of reactors used in practice, which will be discussed later. The fuel elements are inserted in the reactor core. The control rods are introduced and positioned in the core to control the chain reaction. Heavy water reactor acts as a moderator as well as a coolant. The moderator is a main function is to cool the reactor. The heat liberated in the reactor as a result of nuclear fission of the fuel is taken by the coolant circulating through the reactor core. Hot coolant coming out of the reactor core is then circulated through the tubes of steam generator to generate the steam. The water coming out of the heat exchanger is circulated by the pump to maintain the pressure in the circuit in the range of 100 bar to 130 bar. The steam produced expands in the steam turbine for producing work. Steam coming out of the turbine flows to the condenser for condensation. The steam turbine in turn runs an electric generator, thereby producing electrical energy. Next, we are going to discuss about nuclear reactor. A nuclear reactor is similar to the furnace of a steam power plant or combustion chamber of a gas turbine plant. In this nuclear reactor, heat is produced due to nuclear fission chain reaction. The various components of nuclear reactor. First one, nuclear core. Second one, moderator. Third one, control rods. Fourth one, reflector. Fifth one, cooling system. Sixth one, reactor vessels. Last one, biological shielding. Reactor core. It consists of nuclear fuel, the neutron moderator, and space for the coolant. The nuclear fuel is an element or isotope. Nuclear undergo nuclear fission by nuclear bombardment and produce a fission chain reaction. Nuclear fuel may be one or all the following: uranium-235, uranium-233, and plutonium-239. Reactor core generally has a shape approximately a right circular cylinder with a diameter ranging from 0.5 meter to 15 meter. The fuel elements are made of plates of rods of uranium metal. These plates are usually clad in a thin sheet of stainless steel, zingorium or aluminum to provide corrosion resistance. The fuel is shaped and located in such a way heat produced in the reactor is uniform. Second, moderator. The process of slow down the neutrons from high velocity without capturing is known as moderation. Moderator is a material which is used to slow down the neutrons from high velocity without capturing. The fast moving neutrons are far less effective in causing the fission and try to escape from the reactor. Thus, the speed of fast moving neutrons reduced by introducing moderator. A good moderator should possess the following properties: high thermal conductivity, high slowing down power, low practice capture, high resistance to corrosion, stability under heat and radiation. Then control rods. The function of the control rods to control the rate of fission, to start the nuclear chain reaction when reactor is started from cold, to shut down the reactor under emergency condition, to maintain the chain reactor as a steady state, to prevent the melting of fuel rods. Then reflector. Reflector material is placed around the core to reflect back some of the neutrons that leak out from the surface of the core. The reflected neutrons causes more fission and improve the neutrons economy of the reactor. Reflector is generally made of the same material as the moderators: water, carbon, graphite, and generally used as reflectors. Cooling system. The coulomps are used to carry away heat produced inside the reactor to the heat exchanger. From the heat exchanger, heat is transferred to another working media for further utilization of power generation. The desirable properties for a reactor coolant: low melting point, high boiling point, low viscosity, non-corrosive, non-toxicity, low practice capture, high specific heat, high density. Reactor vessel. The reactor vessel encloses the reactor core, moderator, reflector, shield, and control rods. It is starting wall container to withstand high pressure. At the top of the vessel, holes are provided to insert control rods. At the bottom of the vessel, the reactor core is placed. Last one, biological shielding. Shielding is necessary to protect the walls of the reactor vessels from radiation damage and also protect the operating personnel from exposure to radiation. Thick layers of lead concrete or steel are provided all around the reactor. These layers absorb the gamma rays, neutrons, etc. A good shielding material should have the following properties: it should have uniform density, it should not be decomposed by radiation, it should not be fire resistance. These all are the references. Thank you.